After knowing all the concepts of the beam bending, alright, let's take a look at how to calculate the moment. Because once you calculate the moment, if you remember, m over I, you can rearrange things and find your stress. Alright, your Von versus stress is whatever stress that you want, your bending stress. Okay, so this is the thing that we're going to talk about, and therefore let's continue from the previous video.
Beam, we add up the contributions of stress from each area of the cross-section using the moment equation. In this case, it is convenient to break the integral into three pieces, namely the top plastic region, the elastic region, and the bottom plastic region. In the elastic region, where stress equals E times strain, or minus E times Y over rho, the moment contributed by the...
And if you take a look, EY over R is simply your, if you were to rearrange this thing over here, alright, you'll have EY over R is equals to your stress. Okay, so far so good, and therefore let's continue first and see how it goes.
This area equals the integral of Y times E times Y over rho times dA. In the plastic regions of the section, where stress equals plus or minus the yield stress, the moment contributed by these areas equals the integral of Y times the positive or negative yield stress times dA.
And you may wonder, why is this Y over here? Alright, maybe I should crop it out. Because this whole thing over here is your force, and this whole thing is your small area. So, is this the force? Wait, okay, I should say that stress times area is your force. So force times your perpendicular distance y, because its force is acting on over here, or into this picture, while the y is in fact the distance from the neutral axis. Alright, and therefore, this is the moment. So what you're doing now is to plot out the moment of the stuff. Therefore, let's continue first and see how.
The total moment carried by the section is the sum of these three contributions.
And you may wonder, why is this, maybe I should pause this video and crop things up a little bit, hold on a while. Yeah, why do you have this negative over here? Okay, if I were to set the moment, the direction as this is plus, this is minus, alright, then if you, let's say you have a beam over here, in the 2D view, and then if you were to bend it, your top part is going to experience a compressive one, right? It's going into this direction plus, while this one will go in the negative direction minus, and therefore the bottom plane is minus, while the top plane is simply plus. Okay? And the middle one is just some arbitrary linear system talking about the EY over R equals to your stress. Alright, so therefore this whole thing is your stress times your area times your perpendicular distance. You have your moment. Alright, and there may be some discrepancies in my understandings. This is something that I find it kind of useful, and this is the moment of a beam in bending. Later on we'll use it soon. Alright, so I'll see you in the next video for other stuff.